Imagine holding a simple concrete block in your hand. It looks ordinary, almost boring, right? But what if I told you that this small, gray brick is part of a global system moving billions of tons of material every year? Most people never think about it, but these blocks literally hold up entire cities. And what you're about to see will completely change how you look at them forever. Think about this. Every house, every school, every warehouse you've ever walked into likely started with blocks just like this. But here's what nobody tells you. These aren't just molded pieces of cement. They're engineered down to the millimeter, designed to carry massive loads without cracking under pressure. And the journey from raw earth to finished block is far more intense than you'd expect. We're about to go inside one of the most powerful manufacturing processes on Earth. You'll hear machines shaking the ground, see materials transformed under crushing force, and discover secrets hidden inside something you've ignored your whole life. And trust me, what happens next surprised even experienced engineers. It all begins with something incredibly simple: sand, gravel, cement, and water. But not just any sand. High-quality silica sand often comes from riverbeds in countries like India or Pakistan, with purity levels reaching over 95%. The gravel? Crushed stone from quarries in places like the United States or China, carefully graded by size. Even the cement has a story, made by heating limestone to over 1,450 degrees Celsius, creating a fine powder that reacts with water like a controlled explosion. But here's the part most people never see: the scale. A single factory can consume over 200 tons of raw material every day. Trucks travel hundreds of kilometers, burning fuel, hauling these heavy loads just to keep production running. And every grain matters. If the sand is too fine or the gravel too coarse, the entire batch can fail. So before anything even begins, these materials go through intense screening and testing. And this is where it gets truly extraordinary: the environmental cost. Cement production alone contributes nearly 8% of global CO2 emissions. Think about that. Every block you see has a hidden carbon footprint. That's why modern factories are racing to use recycled materials, fly ash, and alternative binders. But even with innovation, the demand keeps rising. And the question is, can this process ever become truly sustainable? Now the real transformation begins. The raw materials enter massive mixers, machines so powerful they can blend hundreds of kilograms in minutes. Inside, the mix spins at around 20 to 30 revolutions per minute. Water is added precisely, triggering a chemical reaction called hydration. You can almost hear the mixture coming alive, thick, heavy, and moving like wet stone. But here's what nobody tells you: timing is everything. From the moment water touches cement, the clock starts ticking. Workers and machines must move fast, because within minutes, the mixture begins to harden. Too slow, and it becomes useless. Too fast, and the structure weakens. It's a race against chemistry itself. The mixture is then fed into block molding machines. These machines don't just shape the blocks, they compress them under extreme pressure, often exceeding 3,000 psi. At the same time, high-frequency vibration, up to 4,000 vibrations per minute, removes air pockets. The ground literally shakes as the blocks take form. And this is the moment everything changes. What was once loose material becomes solid structure. The blocks slide out, still fragile, still warm, like newborns in an industrial world. Workers handle them carefully, because one wrong move can ruin hours of work. But they're not finished yet, not even close. Next comes curing, the hidden stage that defines strength. The blocks are moved into controlled chambers where temperature and humidity are carefully managed. Typically around 60 degrees Celsius and high humidity, this process can last 24 to 48 hours. Inside, the chemical reaction continues, bonding particles together at a microscopic level. What happens next surprised even experienced engineers. These blocks, which looked soft just hours ago, can now enormous weight, sometimes over 1,500 psi compressive strength. And yet, the process still isn't over. Because strength alone isn't enough. Precision matters. And this is where technology takes control. Modern factories use AI-powered vision systems to inspect every block. High-speed cameras scan for cracks, chips, or imperfections as small as 0.5 millimeters. If even one defect is detected, the block is rejected instantly. Rejection rates can reach up to 5%, thousands of blocks every day. Robotic arms move with precision, stacking blocks at speeds humans can match, sometimes over 1,200 blocks per hour. Sensors monitor weight, density, and moisture in real time. But here's something unexpected. Despite all this automation, experienced human workers still outperform machines in spotting subtle flaws. Now zoom out for a second. Globally, over 3 billion concrete blocks are produced every year. The market value? More than $300 billion. Countries like China, India, the United States, Brazil, and Germany dominate production. And millions of workers depend on this industry for their livelihood. But here's something that might shock you. 50 years ago, most blocks were made by hand, slow, inconsistent, and exhausting. Today, a single automated plant can produce in 1 hour what used to take days. And in the next decade, fully autonomous factories could push production even further. Did you know some modern blocks are designed to interlock like Lego pieces? Or that lightweight variants can float on water before curing? Or that special high-strength blocks are used in earthquake-resistant buildings? These aren't just bricks anymore, they're engineered solutions. And now, after everything you've seen, from raw earth to precision engineering, you start to realize something. This simple gray block is anything but simple. It's a product of science, labor, energy, and innovation working together in perfect balance. The next time you walk past a building, stop for a second. Look at the walls. Imagine the journey hidden inside every single block. Because what looks ordinary on the outside carries an extraordinary story within. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.